Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, today we're going to get started on the Pythagorean theorem. This is the official lesson where it gets introduced to you. But before we get into what the Pythagorean theorem is, I like to tell this story. It's a lot more fun, I'm sure, to tell it in front of a group of students rather than to a video. But I didn't realize this until a number of years ago when a former student of mine had sent me an email her senior year in high school saying that she would have gotten one more problem correct on her senior philosophy exam, final exam, if I had told this story in 8th grade. So here it goes. Pythagoras was a philosopher. Let me see, I'll pull up a little picture of him. You can do a little Wikipedia search or whatever to learn more about Pythagoras, but he was born, in the 500 or so BC, somewhere in that area. And he wasn't just known for math. He was kind of a religious philosopher. He had a lot of different beliefs. And one of the things that he strongly believed in was he was vegetarian. Although during that time period they didn't call it vegetarianism, but he didn't feel like it was appropriate for any human being to eat something that at one time was like a living, thinking creature. So he decided, no meat for me. I'm just going to eat plants. And that was a part of his teaching, and he was gathering quite a following with that as one of his major beliefs, but also his philosophies and stuff. Well, what we have today in society, where you have different religious groups sort of battling with each other for what is the truth. Well, the same was the case 2,500 years ago. So there were other philosophers who were rivals of Pythagoras, and they didn't like his teachings. They thought they were the ones who were right, and their followers were rabid. It's like, no, you got to follow this dude, not Pythagoras. And the Pythagorean people were like, no, we follow Pythagoras, not your dude. So you can imagine how tensions would build. So I'm going to take a little sidestep here for a second and go a little bit deeper into this vegetarianism with Pythagoras. Not only did he think you should not eat any meat, but he included beans in that as well, legumes, because he felt like beans resembled organs of the body. Like the kidney bean is shaped like a kidney, and other types of beans, garbanzo beans, string beans, you name it. It just, for whatever reason, he felt like, you know what, these are on my list of things not to eat either. And one thing that's kind of interesting is I'm pretty sure they didn't know that much about proteins back then. But for people who are vegetarians, beans are a source of protein that they're missing when they don't eat meats. So it's really interesting how a lot of that ties in with what we know today, which I'm pretty sure they didn't know 2,500 years ago. But at any rate, back to our story about these rival philosophers and their following. Apparently, Pythagoras had upset the followers of another philosopher to such an extent that one night they got into this crazy mob, and I will say they had pitchforks and knives and torches, but I don't know exactly what that evening looked like. And they decided they were going to go and they were going to kill Pythagoras. So sure enough, they got together, they started marching toward Pythagoras's home, and he saw them coming, and he decided he was going to run for his life. And so this angry mob starts chasing Pythagoras with their, what I imagine to be pitchforks and knives and torches and any other tool that could be used to bring harm upon him. And he's running down this road, and then he gets to a cross in the road. It's like a stop sign, and he either has a choice of going straight through a bean field or turning around and facing the mob. But because his religious beliefs were so strong, they didn't feel like anything that was a thinking creature should be killed. And he included beans as a part of that. He did not want to run through this bean field and have this angry mob trample over and kill these bean plants. So he stopped, He turned around and faced the crowd, and they murdered him. The end. Now, I don't know that that's absolutely true. I would recommend you look through Wikipedia and some other things. I've heard that other people believe it's true, but there are some alternative theories to how he died, but none of them are nearly as fun to tell a story about as that one. So there you go. Pythagoras, the creator of the Pythagorean theorem. So what is the Pythagorean theorem? Well, what we noticed in lesson 9.2.1 was that if you took two squares, two smaller squares, and added their areas together, if it was equal, their sum was equal to the area of the largest square, then you could take those corners and put them together and a right triangle would be formed. So that's the basis for the Pythagorean theorem. The Pythagorean theorem says in any right triangle, the sum of the squares of the two shorter sides, which are the legs, which I'll get to in a second, will always equal the square of the largest side, which we call the hypotenuse. So this is very important vocabulary for you to write down. Draw these pictures down. The two sides of a right triangle that are the shortest sides will always form the right angle. Those we call sides A and B. Those are the legs of the right triangle. The longest side is always called the hypotenuse, and it is always called side C. Now, these two shorter sides, whether you call the shortest one A or the medium length one A, doesn't make any difference. They are interchangeable. However, the two of them, one of them has to be A, one of them has to be B. The two shortest sides that make the right angle are the legs of your right triangle. We also have this thing called the converse of the Pythagorean theorem. That's when you take like a rule and you work it backwards. You put it in reverse. So if Pythagorean theorem says when you have a right triangle, the sum of the squares of the two shorter sides will always equal the square of the largest side, then the converse says if you happen to have a situation where the sum of the squares of the two shorter sides is equal to the square of the largest side, then you must be working with the right triangle. And so what we're going to do is we're going to show you pictures of right triangles, and you're going to figure out a missing side length eventually. We might also give you some different side lengths, and you have to prove whether or not these are the sides of a right triangle based on the Pythagorean theorem. All right, so first things first, taking a look at problem number 68. This is sort of a review of what we were doing yesterday. So what I'd like for you to do is pause the video, read through this section for problem number 68 and answer the questions. And then when you feel like you've got an answer for each one of them and you're ready to check and see how you did, unpause the video. Okay, hopefully you just spent 5 or 10 minutes doing some good work there. The directions say use your patterns from lesson 9.2.1 to decide if the squares listed below form a right triangle. So if you've got squares with side lengths of 6, 8, and 10, if those are the side lengths, these are not the areas. So you're going to have to take 6 and square it, which gives you 36, 8 and square it, which gives you 64, and 10 you square it, it gives you 100. So basically what we were asking is 36 plus 64 equal to 100? Yes, it is, which means that these are the sides of a right triangle. Here you've actually got the areas. So these are the squares, they're not the side lengths. So I guess these are the two shorter ones. If you add those together, do they equal 144? And the answer is no. This would end up being an acute triangle because the two shorter ones are greater in area to the largest one. Then two squares with a side length of 5, that means that each one of them has an area of 25, and a square that is 50 square feet. So if these two are 25, this is the largest one. So does 25 plus 25 equal 50? Yes, it does, which means that this would be describing a right triangle. So explain how you know whether these three squares will join at the corners to form a right triangle. Well, we're basically going to say what the definition of the Pythagorean theorem is. If the sum of the two smaller squares is equal to the area of the larger square, their corners will meet to form a right triangle. All right, so this is Pythagorean theorem right here. A squared plus B squared is equal to C squared, where A and B are the legs and C is the hypotenuse. And once again, you can reverse these. You could make the shortest one B and the longer of the two shorter sides A. It doesn't really matter which one of those is which. I just tend to go with the shortest one is A and the medium length one is B, and then the longest always has to be C. So we're going to use the Pythagorean theorem to write an equation for each diagram below. So once again, what I'd like for you to do is for each one of these, write down a squared plus b squared equals c squared. Just write it underneath each one of them after you draw them into your journal. Then take the information that's provided, and what we're going to do is we're going to find the missing areas for this square, and for this square. So go ahead and pause the video. We'll come back in a couple minutes after you've had a chance to draw these in and work through and see if you can figure out what the area of those three unknown squares are. Okay, welcome back. Maybe that took a little bit longer because you had to draw the pictures. Hopefully, please don't be sloppy with the pictures. You know, this is your journal. This is your reference that you're going to use for assessments and tests. So make sure everything is neat and orderly so you can read it 2 weeks from now. All right, so for this first one, we start with our Pythagorean theorem. If you write this in every single time before you start working through the process, I guarantee you're going to have a higher probability of success and less of a chance of making simple mistakes. So what do we have here? These are the two smaller sides. That's a leg, that's a leg. So that would be a squared, and this would be b squared. And the sum of those have to equal c squared because it's a right triangle. So when we add those up, what do we get? We get 43. So this would be 43 square centimeters. For problem B, here's a leg and here's a leg. So I'm going to call this my a squared and that my b squared. Plug those in. What is 8 plus 12? That is 20, which means this one has to be, c squared must be 20 square meters. And this one's a little trickier. People get into this habit, they think with the Pythagorean theorem that they're always going to add the two squares together. But this is c squared. And so this is why it's so important to write out this formula, because we've got a squared and we've got c squared. It's the b squared that is missing. So we're going to plug in the 10 for the a squared and the 25 for the c squared, which means using a little bit of algebra, you're going to have to subtract 10 from each side, and what you get is b squared is equal to 15 square feet. Okay, so in certain situations, they give you the two legs and you've got to figure out the hypotenuse. In other situations, they give you the hypotenuse in one leg. These are the situations where you'll do a subtraction to get to your answer. All right, and I believe this one, no, I guess we've got 2 more pages. All right, so in lesson 9.2.1, you found a relationship between the squares of the sides of the triangle and the type of triangle. Some of them were acute, some were obtuse, some were right. And then you discovered this, once again, the Pythagorean theorem. You discovered that if the sum of the squares of the two shortest sides in a triangle equals the square of the length of the longest side, then that will give you a right triangle. So what we're going to do now is we're going to go with the converse of the Pythagorean theorem. We're going to look at these 3 side lengths, and we're going to determine whether or not these could be the side lengths of a right triangle to see if a squared plus b squared does equal c squared. Then yes, it will be a right triangle. But if they don't, if the sum of these 2 squares do not equal the c squared, then it is not a right triangle. So in each one of these situations, once again, take A, this would be side A, make the middle one side B, and this one side C for all of them. Then you square this, square that, square this. Then you're going to add these 2 guys together and see if their total sum after being squared is equal to this. Go ahead and pause, work through these 4 problems, and then come back to me and we'll go through them together. All right, welcome back. For A, is a squared plus b squared equal to c squared? Well, 15 squared is 225, and 36 squared is 1,296. Do you notice how I put the question mark above this? Because I don't know whether they're equal or not equal, so I'm not going to commit either way. 39 squared is 1,521, so add these two together. Do they add up to 1,521? Let me actually show this on the calculator, because there's a button here for squaring. If we take 15 squared, 15, you can just hit this button right there, the x squared, find out the equivalent one on your scientific calculator, and then write that number down. Then go to your 36, figure out what that is squared, 1296, and then go to 39, figure out what that is squared, 1521. Okay, so now is 225 plus 1296 equal to, yes, it is. So we can conclusively say, yes, this is a right triangle. Those are the two legs of a right triangle, and that's the hypotenuse of the right triangle. For B, is 20 squared plus 21 squared equal to 29 squared? I don't know. 20 squared is 400, and 21 squared is 441, and 29 squared is 841. So is 400 plus 441 841? Turns out it is. So that is also the dimensions. These are the dimensions of a right triangle. For C, is 8 squared plus 9 squared equal to 12 squared? I don't know. 8 squared is 64. Stop it. No, there we go. And 9 squared is 81. 64 and 81, that doesn't make 144. That makes 145. So no, they're not equal to each other, which means that this is not a right triangle. It's close. If you were to actually draw this in and measure the angle, I bet the angle would be very close to a right angle. But it turns out this is just slightly acute. And then for the last example with 4, 7, and 8, is 4 squared plus 7 squared equal to 8 squared? 4 squared is 16. 7 squared is 49. But when you add those together, you get 65. So similar to this, it's close, but it's not a right angle, so it's not a right triangle. So the first two, A and B, were right triangles because A squared plus B squared did equal C squared. But C and D were not, because A squared plus B squared was not equal to C squared. And then the last two problems. Go ahead, copy those down. I think it's pretty self-explanatory. Trying to figure out, using Pythagorean theorem, what is the missing area in these squares. Go ahead and pause it. Come back when you're ready. I'll assume you're ready now. Thank you for pausing and working through these problems and coming back to me. In this case, these are the two legs, so A squared plus B squared has to equal C squared. A squared is 9. B squared is 121. What's the sum of 9 and 121? It is 130. So this should have an area of 130 square meters. These are your two legs. So A squared plus B squared has to equal C squared. So 6 squared is 36 and 8 squared is 64. When you add those two together, they equal 100. So this square would have 100 square inches. For problem C, now we're going to do a subtraction because that's the hypotenuse. So to figure out what this leg is right there, you'd have to take C squared minus B squared. That would give you A squared. So that ends up being 16 and 25. What's 25 minus 16? It's 9. So A squared has to be equal to 9 square feet. And then this one is just basically the formula. A squared plus B squared is going to equal C squared, which means that this in here, you could call it C squared, but really it's the sum of A squared and B squared. So how long is the missing side length in parts B and C? So if this is 100 square inches, what number do you multiply times itself to give you 100 square inches? That would be 10 inches for the length of this hypotenuse here. And if this is 9 square feet, what is the square root of 9? What number do you multiply times itself to give you 9 for an answer? That's got to be 3 feet. All right, so that was Pythagorean theorem. This was the longest lesson I've done so far, primarily because of my awesome story about Pythagoras. Good luck on your homework tonight, and we are going to be working with this formula for the remainder of Chapter 9. Everything we do from this point out is going to be about solving problems where we have right triangles, and we have two sides that we know, but one is missing, and we've got to use the Pythagorean theorem to figure that out. All right. Thank you very much for staying with me, and good luck on your homework. Bye.
Hey, feeling good, like I should.